Fastna med hans större läckor. Okay, so now we are live, so you can go to the YouTube channel. I will mute my microphone. Men det är väl, det ser från början. Okay, so last time I talked about the applications of the chain rule. Okay, I talked about the applications of the chain rule. I will come back to those a little bit harder problems later after we studied actually the product rule and the quotient rule. There are some interesting problems actually going on there, but today, as it is a schedule, I want to talk about the derivative of sine and cosine function, which we still don't know, yes? So let me write these formulas here for you. So far, what we know is that we have this table, we have a function here, its derivative here. If this function is constant, its derivative is 0. If the function is x to the c, c is a constant, c goes down, then I will have x to the c minus 1. Then we learned about the exponential function, c goes down, we have e to power cx. We also learned, oops, that's good to tell me. I don't know, this camera is actually making me crazy sometimes. How is it now? Is it better? No, again, the same. Now I think it's better now, isn't it? I don't know. This is a simple feature. I should be able to turn the autofocus down. I don't know why is that so complicated. I don't know how I can get rid of this autofocus, you know. And it is very hard for me to exactly be careful and just be glued to the board, yes. I don't know exactly what to do, but I will try, because there are two things, light exposure and autofocus. So yeah, so as far as I think the lightning is changing, some things happen on the camera. I will try to, nobody knows about these things. I was thinking that might be some of the people here in the school can help me, but I will try to find it out somehow on the weekends, yeah. But hopefully you can see something now, can't you? Because when I see myself here, it is not blurry. It was blurry when you told it to me. Okay. I will try to remember not to move so much around, okay? So we had a to power cx, and then we had c goes down. I will write a to power cx. Then I need to remember to put an ln of a as a factor there. Today, we want to add two functions to this table, yes? Today, we want to learn about what happens if I have this, and what happens if I have sine, what happens if I have cosine. So this is the topic of lesson today, okay? So it is clear that what we need to do. So everything is now finished. actually see. At least we have one here. So if I want to give the lesson a title, derivative of sine x and cosine x. So suddenly they told me that I cannot have that class, everything that I prepared is actually gone. Okay, so this lesson on the book is on page 88. Okay, so just talk to me. I want to find the derivative of sine of x. What would be the starting point? Yes?
Use the definition.
Yeah, there's the only way. We cannot do anything except that. Yes? So my question is this. My function f of x is sine of x, and then I want to see what is the derivative of this function. What I have is just the definition of the derivative, yes? So it becomes f prime of x is the limit of f of x plus h minus f of x divided by h goes to 0. Okay, and then I calculate this as before, so you have enough experience of writing this at least, but sometimes calculating this is hard, especially, for example, you see in this case. So what is f of x plus h? I go to my function, I replace x everywhere with x plus h. So there is only one place that I see x, I remove it and replace it with x plus h. And then I have minus f of x, which is minus sine x. Okay, I need to calculate this limit. Okay, do you have any idea, for example, how to continue? Because, for example, you see that if I put h equal to 0, as usual, the denominator is 0. This also becomes sine x minus sine x becomes 0 over 0, which is an indeterminate form for a limit. But it is not algebraically so that I can factorize and simplify. So at least I want you to feel the difference, yes, why this limit is not that elementary to calculate as the algebraic ones. But do you have any idea what to do, everyone at home here? This reminds you this in principle should remind you of a formula. That's called addition formula, yes? So if you remember, we had this addition formula in chapter 2, so we know that sine of u plus v is sine of the first one multiplied by the cosine of the second one plus the sine of the second one multiplied by the cosine of the first one. So at least it seems that I can use this formula here. Whether it helps or not, it's another issue. But let us see what we can do. So I can write sine of the first one multiplied by the cosine of the second one, plus sine of the second one times cosine of the first one. This is the expansion of the first term, and then I have minus sine x at the end. Then I have this h in the denominator, and h goes to 0. Okay? Okay, so this term and the last term share the sine x. The point you will see, you need to wait to see why this will work. So I will factor this sine x out here. So this becomes the limit sine x. Then I will have cosine h left from the first one, minus 1 from the last one. And then I will repeat this again. Plus, I would write cosine x times sine h. It doesn't matter. That's a product. And then I divide this by h. H goes to 0. And then I will write it in a slightly different way to write it as sine. I divide this expression by h plus this expression by h. Because that's a sum, I want to divide it by something, I can divide them separately and add the results, yes? So this becomes, and I write it in this form, sine x times cosine h minus 1 over h. This is a product. Plus cosine x times sine h over h, and h goes to 0. Yes? So that's what I have written here is exactly what we had before. So you see that the obstacle here is actually these limits. First of all, you shouldn't be bothered by sine x and cosine x. They are constant here. Why? Because I am calculating the derivative at a given point x. What is my variable is not x here. I have chosen my x, but what I am just changing is just h. I am making h smaller and smaller. So these two shouldn't bother you because they don't depend on the h. They only depend on h. So as far as this limit is concerned, these are constants. So the point is that, can I calculate the limit of this one and the limit of that one? This is the first time that you have trigonometric limits. We haven't studied that. We will not study them systematically. So these are a little bit more advanced theorems. The usual methods for calculating the limit doesn't work. You need to invoke more advanced theorems, okay? But I will actually use the method in the book. So you need to, this is the only way that you can do it. You need to calculate this function for small values of h, see that if you get a feeling about the result. But of course, that feeling is not a mathematical rigorous way of doing that. The book has done this for both of them. I can do this for this one, then we can rigorously prove this one. You don't need to do the method in the book. Okay, so let us do that. But here, so the question, the calculating this limit boils down to these two limits. So if I can answer this limit when h goes to 0 and this limit, then I am done. So now I forget momentarily about the problem itself, focus on answering these question marks. When I found them, I plug them back and I will find my derivative. Okay, let us concentrate here. If you want to find this rigorously, this is beyond the scope of Math 4. You will study it in the university, but for getting a feeling what that number is, we can just usually always do the same thing, yes? But something is very, very important here. And that is this table that I see here is the numbers that I write here for you is only if h is measured in radians. Okay, so let me emphasize this with a different color. H in this table is measured in radians. You can immediately see that if you switch your calculator to the degree mode, it doesn't work, okay? It gives you different numbers. So I will use this data in the book. So if you plug 0.h in the radian mode in your calculator and calculate this, according to the book, you will get this number, 0.99833. Again, I emphasize, switch your calculator to the radian mode plug 0.1 in the radian mode in this function, sine of 0.1 divided by 0.1, use your calculator, you will get this number. Okay? And then make this number a little bit smaller because I'm supposed to send h to 0. If you do this again in the radian mode, you will get this number, 0.39 and then 8. Yes? And then if you just do this one, 0.01 in the radian mode again, you will get 1.00, I don't know, 4 zeros or 5 zeros, 5 zeros, I think, if I can read it properly. And then if you do the next one, you will get exactly the same situation. 1, 2, 3, 4, 5 again. So at least, yeah. These are the numbers that you get. So this already gives you a feeling, but of course it is not clear. That might be the next decimal point, something else. But at least you have the feeling that this limit should be which number? 1. So they are approaching to number 1. So that is the way that the book has done it for this limit, okay? Because it needs a theorem that you haven't studied in the high school, actually. So this gives me that limit of sine h over h is equal to 1 when h goes to 0, measured in radians. So this is important. So you can see that if you do the same calculation and switch your calculator to the degree mode, the number that you see that this is approaching is not 1. That is a problem in the book. I don't want to spoil it right now. I want you to think about it yourself. Okay, so that is the limit. Of course, in the book, they use the same idea for this function, but let me make it a little bit more fun. As far as you know this, you don't need to do the same thing. You can prove this rigorously. You can find that limit rigorously. Okay, but let us have an interpretation here. This tells you that if you have sine of an angle divided by that angle, if that angle goes to 0 in the radian mode, the limit is 1. Interpret it in that way. Now my goal is to calculate this limit. So let me just do it rigorously. How? Do you remember we had a formula of the double angle? Cosine of 2u was 1 minus 2 sine squared u. Do you agree? Mm-hmm. This was the formula that we had. Now, this formula is valid for all possible choices of u. Let me choose u to be h over 2. Okay? So then let us see what happens. This becomes cosine. 2 times u is h, is equal to 1 minus 2 sine to the power of 2 of h over 2. I am replacing u with h over 2 in this known formula. Yes? And then what I do, you see, I need this combination. I need this combination, cosine h minus 1. So I move 1 to the right-hand side. So what happens? This tells me that cosine h minus 1 is equal to negative 2 sine squared h over 2. And what I do, I divide by h to get that one. So let me just do it here, yes? I then divide both sides by h. Okay, now I need to manipulate this a little bit so that I can invoke this idea here. So my goal is to make this combination right. Sine and an arc, sine of an angle divided by the same angle. Unfortunately here, this is h over 2, but the angle here is h, and I have a power of 2. I need to take care of all of them. That is not hard to do. Let me write it and see what is going on. So I will write it as minus 2 times h, okay? Sorry, let me write it in this form. So I need to divide it by 2 to power 2. So let me write this. Let me do it step by step. Okay. I multiply by h, the numerator and the denominator, So this becomes sine squared h over 2. So what I have done, I have just multiplied an h here and then divided by the same h. So this will be cancelled and I will get the same thing. Yes, that's exactly the same. But here, unfortunately, I have h over 2. Here I have h2. I can do something like this. I can write minus 2h, copy and paste this part. I can write sine squared h over 2. I want to make it h over 2 squared. So how can I do that? I would write it and try to fix it in a way. Okay? So you see, if I write it like this, there are some things that I need to take care of, yes? Because when I raise it to power 2, it becomes h squared. That is good, I have it. But when I raise this one to power 2, it becomes 1 over 4 that I don't have it. Yes? So to compensate for that, I multiply a 4 here. Is that clear? So what you need to convince yourself is that this equality is true. That's the only thing. And that's a simple algebra. Okay, so then why this is good? Because you can write it in this way. I put 4 here on the bottom. Minus 2 and 4 will be simplified. It becomes minus h over 2. Yes? And then what I do, I write this as a second power of a fraction. It becomes sine h over 2 divided by h over 2. Is that clear? So that is a simple algebra. But now my point is to calculate the limit of this expression. You see, I want to calculate the limit of this expression, but this expression, according to this algebra, is equal to this expression. So I will focus and calculate this limit. But this limit is easy now. Why? Because it has the right combination. You see, sine of an angle divided by the same angle where the angle goes to 0, yes? Because when h goes to 0, it is clear that h over 2 also goes to 0, yes? So this becomes, so in the limit, so therefore the question mark, which is my limit, when I send h goes to 0, this part becomes 1 to the power of 2 because I use this rule. This limit is 1, then I have the second power. But I also have this one. What is this limit? 0, because h goes to 0. So this is a product. The limit of this one is 0. The limit of this one is 1. So the limit of the product is 0. Yes? So this is at the level of your lesson. This is not hard as far as you agree with this one. But in the book, they have mentioned another column and calculated the values of this. You see that those values are approaching 0. But this is the rigorous proof of this if you already accept this one. But now let us go back. Now I know the answer to both question marks. The first one is 1, the second one is 0. So if I go back here, this becomes equal to sine x multiplied by the limit of this part, I just got it, it is 0, plus cosine x multiplied by the limit of this part according to this rough calculation is 1. And then the answer is very simple. This is totally gone. It becomes cosine x. So the answer to this is clear now. Yes? So this is your question mark that you plug here. So the derivative of sine is simply cosine. So let me complete my table here. So this is cosine. So is that clear? But this is not the whole story. You might ask, what happens if I have sine of something else, not just x? But that is not an obstacle, yes? Do you know what to do? For example, if I ask you to differentiate sine of, for example, this. Let me give you a simple example. If, of course, I ask you sine of x, the answer is simply cosine of x. But let me ask you something a little bit more difficult. What is the derivative of sine x squared plus 5? How do you answer this question? I think that is clear that this method is more or less hopeless, yes, because it becomes very complicated if you want to do it. But you really don't need that. You need to remember something very important. Yes, exactly. The chain rule. Yes, it should be the chain rule. So if I want to calculate this, so it means that whenever you find a new formula, this is not just one single formula. It's a bunch of formulas for all choices of x, yes, because we have the chain rule. So if I want to write the chain rule version, which is not given in the formula sheet, you need to know it yourself. If u is a function of x, so what would be the derivative? It follows the same rule, but you need to remember to multiply by an extra u prime as always, yes? So if I ask you to calculate the derivative of this function, you can, yes? You would say that in my head, I will take this one to be u, then sine of u derivative becomes cosine of u, but I should multiply by an extra u prime. And this is not finished yet because still I have a prime. I continue one more step. It becomes this multiplied by 2x. Yes? And I prefer to write 2x on the left. It is not mandatory, of course. Yeah, so, but it is better. There's no confusion. So remember, I will give you more examples of this type, but this is not just one single formula. It is a class of functions involving sine with any function sine. Now my question is that, what do you think about cosine of x? I want to find the derivative of cosine of x. What is your suggestion? What is your starting point? People at home and here. So let me clean the board so that you can think. So my question is that how to calculate cosine of x? The derivative of cosine of x. May you speak louder, please? Louder, please. Let me see if my voice.
Cosine of x plus b.
So you mean that more or less starting from the definition, yes? Strategy. You mean that I need to? Okay, but I think yes, there is a better trick. Of course, you can start from the beginning again. You can start using the definition of the derivative and do the same thing. You will probably face two trigonometric. I think they are the same more or less. Yes, you will face more or less the same limits. You don't need to find new limits. Okay, if you want, we can do that in that way. Let us do that quickly. Let us see how it goes. So let us do the same process, even though it is not needed. So f prime of x, let us do it quickly. It becomes the limit f of x plus h, in this case, becomes cosine of x plus h, and then minus the function itself divided by h. H goes to 0, yes? But then you have another formula, addition formula for cosine. It becomes cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. For the cosine, the sign is opposite. Yes, and then you have minus cosine x. So you see, you don't need really, the hard part is already done. Yes, and then I take the derivative between these two. So sorry, I factor cosine x out. Let me save time because that's exactly the same thing. And I divide it, and then I will have minus sine x, and then I will have sine h over h. H goes to 0. Yes, that's exactly the same thing. So I factor this out, and then I separately divide. Yes, but you see that the same limits are actually involved here as well. So this limit we calculate is 0. This limit we calculate to be 1. So the answer is 0 totally here. 1 times negative sign, it becomes negative sine x, and that's the correct answer actually. So this is one way of doing that. So I would write minus sine x. This is, so the derivative of sine x is cosine x, but the derivative of cosine x is negative sine x, and that is important to know. But you really didn't need to do this. You can do it a little bit simpler. How? Any clue? You don't need to start from scratch.
The derivative of sine x, but remake cosine of x as cosine of pi over 2 minus x.
Yeah, exactly. So this is the idea. So remember, there is no much difference between sine and cosine. If you remember the graphs, they are actually exactly identical unless one of them is shifted. You can gain it from the shifting of the other one. So this should be in the back of your head. Sine and cosine are not that independent. Okay, so one of them can be obtained from the shift of the other one. So if you have that idea, exactly. So f of x is cosine of x. Do you agree that instead of cosine of x, I can write what? Sine of pi over 2 minus x. This is the same thing. But I don't have any problem with differentiating sine unless I have something in front, but that chain rule will solve my problem for this one, yes? So if I want to take the derivative of this function, forget about cosine, just think about the sine, okay? But this is not sine x, it's something else. That's something else. You should take u in your head. It becomes sine of u. And then if you differentiate it, it becomes cosine of u, which is cosine of pi over 2 minus x, multiplied by u prime, yes? Is that clear? But now if I ask you, what is this one? This is the cosine of the complement angle. So it becomes sine x. Yes, so it becomes sine x. And what is the derivative of this? It's minus 1. Because pi over 2 is a constant, its derivative is 0. It becomes minus 1, and you get the same formula back. Yes? I would say this is more instructive instead of doing everything from scratch all over again. Anyway, these are the formulas that we get at this point, but this is very important to write that x has to be, let me emphasize, has to be, there's no other choice, to be measured in radians. Okay. So it's very important. These formulas take this simple form if you force yourself to measure x in radians. If it is in degrees, I want you to discover it yourself. That's a problem in the book. I will come back to it probably the first thing in the next session. So think about that. What happens if x is measured in degrees and I want to find the formula for this one? And I don't want you to start from scratch. What is the idea? Do you have the idea how to do that if x is measured in radians? The idea, not the detailed calculations. Anyone here or at home? Let me ask you one question. If I ask you differentiate this function, do you know? Yes, chain rule again. Because if I ask you sine of 5x, can you differentiate this?
Yes.
This is chain rule, yes? So what happens? It becomes cosine of 5x, but we need to remember to multiply by the derivative of 5x, which is 5. Okay, if x is expressed in degrees, you can express it in radians, yes? And that, so I don't know, you need to think about that would be a constant multiplied by x in radians. So that's just, so at the end you will get an extra constant. So if you bother to work in degrees, then you will always need to put a constant here, okay? But if you work in radians, the formulas are simpler. And then radians is actually the only one that we will work from now on. Okay, but that's a good thing to think about. Think about this yourself. And that's the problem in the book, by the way. Okay, more or less the lesson is finished. I don't want to continue more, but we can just do some exercises together and then we are done. Okay, and then 2 more are left here. So I want to, the next lesson is that what will happen if I have ln of x here. After that, I will teach about the product rule and the quotient rule, and then finally the derivative of tangent, and that would be the final table that we will have. Okay, so let me just do some examples here for you. So of course, it is clear that the main important thing is the chain rule. So to respect the chain rule. So differentiate. By my experience, I don't know, some people find this hard. I want you to ask, do you also find it hard or not? Sine to the power of 3x. Let me write it too, yes. You want to differentiate this function. Okay, can you help me to do that? What should I do? First of all, let me review. Is this function exactly in my table? No. So there is no way. I have to reduce it in one of those forms, probably using the chain rule or other rules in combination. There is no other rules involved here because there is only one single part. So might be this should be the chain rule. But you need to take something as u. What is the choice?
Sine x.
Sine x to be u.
Yes.
Yes. The reason I don't know, for some reason people want to do it quickly. They write 2 cosine x. Yeah, so that is not correct. Okay. The reason is that they are actually doing something very fast. So this is the good choice for having it u. Then in a scratch paper, it is u to the 2. So it means that this is the old lesson. This doesn't involve the new lesson so far because this is u to power 2. Yes. So then I will start differentiating it. What would be the answer? 2 goes down. U, so the answer is 2u, but u prime. So u itself has to be written and then multiplied by u prime. Yes? So I don't know, some people do it fast and then they don't remember to write this part, which is the simple part, of course. So this becomes 2 sine x, and the derivative of sine is cosine x. Of course, you can leave it like that, but that's also a famous formula in trigonometry. 2 sine x, cosine x is the sine of double angle. So that's very nice. So the derivative of sine squared. So that's very nice. So the derivative of sine squared x, it seems that 2 just goes there. Yes. This is just a coincidence. Any questions? Okay, let us just start solving some problems and then we go on. So number 2. What if I have this situation? F of x, let me make it a little bit harder. So, let me write this time cosine. Cosine of square root of x squared plus 5x, and this one to power 3. Something like this. So this is power 3, not the third root. So if you want, I can put it in pair of brackets. It's not necessary, but let us just do it. So if you want, I can put it in pair of brackets. It's not necessary, but let us just do it. So we want to differentiate this function now. Now I want to give you a little bit of time to think about this problem yourself first. Now I will wait a little bit for you. Yeah, if you are done, I can write one more here and then we are done. Yeah, so if you can really do these two things, it means that you understood everything regarding the chain rule. So let me add something to this as well.
Mr. Babak, could you move
Yeah.
the camera so that the number 3 is more in view? Because I can't see what
That is, so it is the first, the number 2 or number 3?
no, I can see. Thank you.
I don't know, it should be very simple to,
Yeah.
because you need a software to control
do
it.
Yeah.
But when you do it on YouTube, that software doesn't work. There should be a video setting in the YouTube itself so that you can control it. Okay, should I start solving that? So here, number 2. So what do you think? What is the good choice? Here we have some choices here. Might be you think this can be taken as u, or you might think that this can be taken as u, or the final one. So which one is suitable at this stage?
The final.
The whole expression, yes, because it gives you u3. So at this stage, I will take this one to be u, and it becomes u to the 3. And if I differentiate it, it becomes 3u to the 2. So 3u to the 2. I copy the paste u, but multiplied by the u prime. So this is one step. But then that is, I have to copy and paste this part and then concentrate on calculating that second part. Okay, then what should I do? Take the square root to be u, yes? So then I will take this one, which was not good in the beginning, but this is a suitable choice right now. It becomes cosine of u. The derivative of cosine includes a negative sign, so I have to multiply by negative sine of u, which is that one. But it is not finished yet. Multiply by the derivative of u itself. Yes? And still it's not finished because I have a prime, but let me organize it a little bit. So this minus will be multiplied by this 3, it becomes negative 3. This is the copy-paste part, so I have to do it quickly. And then I go to the next one. This is, again, another chain rule, yes? So this time I will take this one to be u. It becomes square root of u, and hopefully I told you it's better to remember, otherwise this very tedious, you want to do it every time, so it becomes 2 over square root of u, but multiplied by u prime. So then this becomes 1 over 2 square root of u multiplied by u prime. So if you want to write everything in detail, this is the way, but usually it is easy to calculate this in head, and you can calculate most of it in your head if you can do that. So it becomes minus 3. And this is 2x plus 5. So let me write them in one go. So it becomes minus 3. I will write 2x plus 5 here. Then I have cosine squared, square root of x squared plus 5x. Then I will have times sine of the square root of x squared plus 5x. And then the denominator is this expression, 2 square root of x squared plus 5x. So if you really can understand and follow what I said, it means that you really understood what is the meaning of the chain rule and you don't have any problem in differentiation. But of course, you need to watch out about your calculations. Don't do any miscalculation. Is that clear? Yes? Okay, so for the next one, the story is more or less the same, but I also have to use addition rule as well. Yes? So let us write that one as well, and then we are done. Okay, so how should I calculate this derivative of this? So g prime of x is equal. Here I have the sum of two functions, so I need to differentiate this one and that one separately and add them. For this one, that 3 is a constant. So here, I hope that you now that you know this is u. So 5 goes down, so let me write it here. It becomes 15. And then u to power 4, which becomes sine to the power of 4 square root of 1 plus e to power x squared plus 1. And then multiplied by the derivative of u, which is sine of square root of 1 e to power x squared plus 1 prime. Let us do them in parallel, okay? And then here, I have a 5, 2 goes down, it becomes 10. This becomes cosine of u, yes, but multiplied by the derivative of cosine of 3x prime, yes? That's the idea. Yeah, let us skip the steps if possible, if you are not confused, yes? Please let me know if not. So here, what can I do? sine becomes cosine. I am taking this to be u. So this becomes cosine of u multiplied by the derivative of u. Yes? And then go to the next one. What is the derivative of cosine of u? It becomes minus sine, so it becomes minus 10. And cosine 3x, sine 3x. But it is not finished. You need to multiply by the derivative of 3x. So then 15 sine to the power of 4 square root of 1 e to power x squared plus 1 multiplied by cosine square root of 1 e to power x squared plus 1. What is the derivative of a square root? It is 2 over that expression, but multiplied by the derivative of this one. But this becomes 3, let me multiply it here, so it becomes minus 30 cosine 3x sine 3x. So here I have the sum rule and the chain rule, yes? But the derivative of 1 is 0, so I need to focus the derivative here. So this becomes finally 15 sine to the 4 square root of 1 e to power x squared plus 1 cosine of 1 plus e to power x squared plus 1 multiplied by this. Okay, now can you do this in your head? What is the answer to this? 1 plus e to power x squared plus 1, because it also needs a chain rule, yes? So the derivative of the first one is 0. The derivative of e to power u becomes e to power u, but you need to multiply by the derivative of u, which becomes 2x. So this becomes 2x e to power x squared plus 1, yes? And then the rest of it, minus 30 cosine 3x sine 3x. This is a very artificial function, but I was just focusing on how to differentiate. So if you see that, if you are not confused, it is tedious, but it is possible. But be careful. You need to really value the chain rule. As soon as you want to calculate this derivative using the definition of the derivative, it's hopeless. Yes? So the chain rule is actually a very, very powerful tool so that we can calculate the derivative of very complicated functions fairly easily. Okay? Is that clear? Okay, so I will stop here. So the questions are on this page if you want to work on yourself. Of course, I will always write on a school soft. And one thing I want to talk about is the YouTube channel. I have added a playlist, I don't know have you seen it or not, for interested students. So I don't know, I have put 11 videos for math so far. There are only one problem, one solution. But the problems are hard. The knowledge that you need is at the level of math 4, but you need to be a little bit creative if in case you are interested in solving harder problems. Okay. I can, if you want, you can be here, or if you want, we can finish the lesson. Anyway, I will end this live stream. I will go back to Zoom to see if you have any questions. Otherwise, we can end the lesson. Okay, thank you for listening.